and 51 is a blank page. You actually have some, I would actually start on page 650 underneath the study note, because we're going to use this for another type of common question that comes up called pi over 12 questions. You know when you did your unit circle, you have 30, 45, and 60, and the gap between 0 and 30 is 30 degrees, but between 30 and 45 is 15 degrees? If things were spaced out equally, you would need to have 15 degrees labeled in there as well. Now that we've done these new formulas, alpha plus beta formulas for sine and cos, we can find the exact values of all of those ones that are in between as well. We could add them to our unit circle, but our unit circle would get very full, and they're not easy ones to memorize. They're easy ones to figure out. So they're called pi over 12 questions or 15-degree questions. And they're any angles that fall in between the axis and either pi over 6 or the y-axis and a pi over 3 family. So we want to find what's the exact value of cos of pi over 12. Our solution is that we have to convert our family members that we already know, pi over 3, pi over 4, and pi over 6, which could all be represented as something over 12 with a common denominator, and you have to add or subtract until you get the pi over 12 angle you want to find. Now, you're not restricted to only use those first three. You can use any family member that you like. Now, the red stuff that I have written in there, we'll look at a little bit later. But once we change each of those to pi over 12, 4 pi over 12, 3 pi over 12, and 2 pi over 12, can you see a way that you could add or subtract to get 1 pi over 12 using two of them? Yes? Yeah, if you subtract 4 pi over 12 minus 3 pi over 12, can you see that you could get 1 pi over 12? And you could also do 3 pi over 12 minus 2 pi over 12. That would also give you 1 pi over 12. So what we do as a technique is once we find two of them that add or subtract to get what we want, we can write out, well, I know that cos of pi over 12 is equal to cos 4 pi over 12 minus 3 pi over 12. Now, the reason this is helpful is because both of those, the 4 pi over 12 and the 3 pi over 12, they reduce, of course, to pi over 3 and pi over 4. And if we're subtracting, this can be our alpha and this can be our beta. And we have a cos alpha minus beta formula. What do we know? Well, we could write it out, cos alpha, cos beta, plus sine alpha, sine beta. That's our cos alpha minus beta formula. And all of these values are on our original pi plate. What is cos of pi over 3? What's cos of pi over 4? Do you remember them? This is root 2 over 2. This is 1/2, this one, root 3 over 2. So evaluate each of them separately. 1/2, root 2 over 2, root 3 over 2, root 2 over 2 again. We need to find an exact value, so our final answer has to be a single fraction. How do we multiply fractions? Multiply the numerators, multiply the denominators. Can you see that you're going to already have a common denominator of 4? So then you just need to add the tops. And it will be all over 4. And I'll get you to finish it up from here, and then I'll put up the answer in a bit. I'll hand out some scrap paper because the next thing that we're going to do is going to require scrap paper. I think I need one more. Fancy, you get the big one. All right, quick check to see if you were able to get it. Root 6 plus root 2 divided by 4. Do you notice our answer in the first one was root 2 and root 6 divided by 4? For all pi over 12 families, for sine and cos, you will always have a root 2, you will always have a root 6, it'll always be over 4. What changes is what's positive and negative. Sometimes both the root 6 and the root 2 are negative. Sometimes only one of them is negative. Sometimes, like in this situation, they're both positive. So I gave you all a scrap piece of paper. What we're going to do next is go to a bigger angle, 17 pi over 12. Okay? Now, to get 17 pi over 12, you can't use 3 pi over 4 plus 4 pi over 3 pi over 12 plus 4 pi over 12. The numbers aren't big enough. You're going to need to use a different family member, maybe something from quadrant 2, or something from quadrant 3, or something from quadrant 4. For example, if you choose, tell me one of the pi plate ones in quadrant 3 that you know. What do you know in quadrant 3? 4 pi over 3. Okay. 4 pi over 3 is 16 pi over 12. Right? If I get a denominator of 12. What you need to figure out, okay, is two angles that are on your pi plate or anything coterminal on your pi plate. You can even go 10 times around if you'd like. I might make it more difficult, but you could do that. You have to find two angles that add up to 17 pi over 12. Once you find one, you're going to want to call me over quickly, because as soon as you find one, I'm going to write it up on the board, and then nobody else is allowed to use that one. They have to find a different one. So everybody's trying to find one, but as soon as it goes up there, sometimes it happens that you find the same one just after someone else found, then you got to start over. And there's an infinite amount of right answers. So it's not like we're going to run out. So you can start. Go. Okay, so now we came up with 8 different ways to get 17 pi over 12 using values on our pi plate. The question is, if we get a question like this on the test, how fast can we find one of them? There must be a pattern or something to help us find one of them. Okay, they all add up to 17 pi over 12. That's not the pattern. But if we look at each individual one, what do they have in common? What happens every single time we try to get a pi over 12? You see anything in common with all 8 of those? There is a pi over 4 in every single one of them. Here we have a pi over 4, different pi over 4 family, different pi over 4, different pi over 4, different pi over 4. This one was way far past any of the pi over 4s we had. And in the last one, I gave you a pi over 4, and then how hard was it to find the other one that went with it once you have one of the pi over 4s? Not very hard at all. So when finding any pi over 12, you can start with any pi over 4 you want. So for example, if you started with 5 pi over 4, well, 5 pi over 4 happens to be 15 pi over 12. How hard is it to figure out what you need to add to get 17 pi over 12? Not very hard at all. What do you have to add to 15 to get 17? 2. So that makes 17. Does this reduce nicely to be on our unit circle? It does. In fact, every time you start with a pi over 12, here's 9 pi over 12. What would I have to add to get 17? 8 pi over 12. Sure enough, that reduces to something on your pi plate. If you don't choose a pi over 4, you're not guaranteed that they'll reduce to be something on your pi plate. The reason you have to use a pi over 4 was on our notes here. Pi over 4 is the only one that's odd. Pi over 4 makes 3 pi over 12. Pi over 3 and pi over 6 are both even numbers over 12. Any multiple of them will still be an even number over 12. If you're trying to find 17 pi over 12, you need 2 numbers to add to 17. One of them is going to be odd, one of them is going to be even. The only way to get an odd number is to use something in your pi over 4 family. So there are people that always use just plain pi over 4. Right? What's plain pi over 4? 3 pi over 12. What would I have to add to get to 17? 14 pi over 12. That reduces nicely to 7 pi over 6. Then we're good to go. Some people like to pick a pi over 4 that's close to the number they want to get. So we wanted to get 17, so they're like, ooh, I want to choose 5 pi over 4 because it's close. Okay? What did I do in the purple one? I picked a big pi over 4 family member. So the mental math isn't as nice here. You have 63 pi over 12. What would I have to subtract to get 17? I'd have to subtract 46 pi over 12. But sure enough, when that reduced, it happens to be a pi over 6 family. Not very much fun to deal with this because you have to know what quadrants these are in. There's more work involved than all of these other ones. We're using values that are in our first time around, except for the 9 pi over 4 is in quadrant 1 in the second time around. And it doesn't matter which one you choose. When you simplify it, you will get the exact same answer. So I've got an example here of choosing one of them. Okay, we want to find the exact value of cos of pi over 12. The hint, always start with a pi over 4 family. Doesn't matter which one. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And you can go beyond that if you want. So here I happen to choose 7 pi over 4. Well, 7 pi over 4 is too much, 21. I'd have to subtract 4 to get to 17. Now I have to use my cos alpha minus beta formula. I reduce both of those. As we're showing our work, the cos is out in front, the cos is out in front, the angles, these angles add up to this one, these ones reduce. And now we can expand it completely. Everything else is on our unit circle. Now with your unit circle, not only do you need to know that cos of pi over 4 is root 2 over 2, you also have to know that this is in quadrant 4, so cos is still positive. Some of these, like sine of 7 pi over 4, that's in quadrant 4, it's going to be negative. Because one of them has to be pi over 4, can you see that you'll always get the root 2 over 2 twice? And the other one's going to be pi over 3 or pi over 6, so you're going to get a half and a root 3 over 2. Which means once we simplify this, we always get a root 2, a root 6, and over 4. Just what changes is what's positive and what's negative. And sometimes after figuring out a cos of pi over 12 questions, sometimes an exam has a part B where it says, can you now figure out what secant of 17 pi over 12 is? If you know cos of 17 pi over 12 is this, the answer will just be the reciprocal for secant. Even if you got part A completely wrong and got an answer of 1/3, in part B on the exam, if they ask secant and you take your 1/3 and you flip it, they give you full marks, even if you flip the wrong answer. Because they're just checking to see if you know that secant is the reciprocal. Okay. Here is a harder one from an exam, and then you can also do number 7 from your homework. This one was harder on the exam. Why? Because it had a 4 out in front. What does that 4 mean? 4 times this. So if you figure out this by itself first, all you'd have to do in the end would be to multiply by 4. But it was amazing when this was on the exam, right? All of a sudden nobody could do it. Just a little bit different. It's like if you teach kids in grade 4 multiplication, you're like, do you know what 3 times 4 is? Yeah. Do you know what 2 plus 2 is? Yeah. Can you do 2 plus 2 times 3? No. Too many steps. This is the same example what happened in grade 12 here. That extra 4 in front caused people problems. It's really not that hard. You just do the cos of 11 pi over 12 first. You're going to get a root 6, a root 2 all over 4. What's going to happen when you multiply by 4? It's going to cancel out with that 4 on the bottom. And the final answer will just be a root 6 and a root 2. Some positive, some negatives.